All right, welcome. Today we're diving into a theoretical paper that puts forward a pretty wild idea. What if one of the most fundamental numbers in all of physics isn't just some random constant? What if it's directly mathematically linked to the speed of our entire solar system as it zips through the galaxy? It's a really cool thought, right? Connecting the tiny world of particles to the massive scale of galactic motion. Let's dig in. So this is the big question the whole theory is built on. Could there be some hidden connection, some elegant piece of math that ties the speed of light, the absolute speed limit of the universe, to the speed our solar system is traveling right now through the Milky Way? It's a bold claim, for sure. And the author says the key to it all is one very, very special number. And here's our main character. This is the fine structure constant, also known as alpha. Now, in the world of physics, this little number is a huge deal. It's about 1 over 137. It doesn't have any units, it's just a pure number. Think of it as the volume knob for electromagnetism. It basically sets the strength of the interaction between charged particles, like electrons, and light. I mean, it's absolutely fundamental to, everything. But what this paper is suggesting is that maybe, just maybe, it has another job, a much more cosmic one. Okay, so to really get what the author is proposing, we've got to define our terms. C is easy. That's the speed of light. You know this one. But V, now this is where it gets interesting. For this theory, V isn't just any old velocity. We're talking specifically about the speed of our solar system as it moves through the galaxy. That's it. That's V. And boom, here's the core of the whole thing. It's this incredibly simple equation. Take C, the speed of light, and divide it by V, our solar system's speed, and you get alpha, the fine structure constant. Just like that. See what this does? It totally reframes what alpha is. All of a sudden, it's not just some abstract number physicists found. It's a direct relationship, a ratio, between two of the most fundamental speeds in the cosmos. Okay, so what exactly is that galactic speed we're talking about? Well, the paper puts a number on it. It says RV is, on average, 820,000 kilometers per hour. Now that sounds fast, but let's break it down. That's about 230 kilometers every single second. Just, wow, think about that. That's how fast the author is saying we're all hurtling around the center of our galaxy right now. So if you just flip that last equation around a little bit, you get the speed of light equals alpha times our galactic velocity. And this is where we get the author's big idea, that alpha, the fine structure constant, is actually a multiplier of galactic motion. It's literally the number you multiply our speed by to get to the speed of light. It's like a cosmic gear ratio, in a way. All right, and from here, the paper really starts to branch out into some pretty speculative territory. The idea is that this principle, this relationship, isn't just a 3D thing. No, it extends into higher dimensions, forming what the author calls streams. So you've got your 4D space-time streams, which, relativity fans will recognize that. But then it goes further, talking about 5D space volume streams, and even 11D space density streams. Now we're getting into concepts you might see in something like string theory. And if you thought that was a leap, hold on. The paper then suggests that these streams could also be the multiplier of cosmic wormhole motion. So what's happening here is the author is taking that same core idea, a simple multiplier linking two speeds, and applying it to this super theoretical world of cosmic wormholes. It's a pretty big jump. Okay, so now the paper kind of shifts gears for a moment. It lays out this really interesting model of a neutrino's journey, starting from inside the Earth and moving out. And what's fascinating is that it assigns a different equation for the neutrino's energy depending on where it is. So deep in the Earth's core, it's described by one formula. Then, as it travels through the mantle, that formula changes. And then finally, when it gets to the surface, it resolves into the one we all know and love, E equals mc squared. The important part isn't really the specific math, it's the idea that the very nature of this energy equation changes as the particle moves through different layers of the planet. So here's where the author tries to tie everything we've talked about, the galactic motion, the neutrino journey, into one single unifying equation. Let's look at what's happening. It takes that equation from the Earth's core, but see that V term? It's been replaced with alpha V. It's plugging our galactic multiplier right into the neutrino energy model. This is it. This is the paper's grand unified idea, trying to connect all these dots. And then, the paper makes a really surprising connection, jumping from theoretical physics all the way over to spirituality. The author says this whole system of equations and streams is like a sacred plate of cymatics. Now, if you haven't heard of cymatics, it's that amazing phenomenon where you put sand on a metal plate, vibrate it with a sound frequency, and the sand arranges itself into these beautiful, intricate geometric patterns. So the suggestion is that this physics framework is a kind of cosmic vibration, creating a pattern. And this is then linked to Gaggan Mein Thal, which is a sacred Sikh verse that poetically describes the sun, moon, and stars as items on a cosmic platter of worship. It's a powerful metaphor. So that leaves us with a really thought-provoking question to chew on. We've journeyed through fundamental constants, some pretty out-there theoretical physics, and ended up with sacred hymns. And it's not really about picking a side, is it? It's more about asking, what happens when we use these two very different languages, the language of physics and the language of spirituality, to try and describe the very same universe we're all living in? It's a really interesting place where ideas meet. Thanks for digging into this one with us.